Okay, number 38, we have a cosine equation given to us. We are measuring the depth of water at a certain time, hours after midnight, because the tide is going in and out, so the water is getting deeper, shallower, etc. Okay, first thing, we're going to do a lot of this in the calculator, so let's see if we can very carefully get that entered in correctly, set our mode, set our window, because that sometimes is the barrier to this particular problem, is just getting all of that in there as needed. So let's go ahead and put in our y equals 3 plus 4 cosine of pi over 5.7. I'm not going to close my parentheses here. If I do, I'm not actually plugging x into cosine. And I want to open up another set of parentheses for that x minus 2. Okay, so just take a look at how that's typed in. Now, I know that's in radians, so I'm just checking that my mode, good to go, I'm in radian mode. My window, if I look at my sinusoidal axis and amplitude, let's do the vertical stuff first. So my axis is at 3, my amplitude is at 4. Negative 10 to 10 is probably fine. I'm going to go maybe negative 5 to 10, just so I can focus on the graph a little bit more there. And then my x min and max, that's the time. So I don't want a whole lot of negative here. I'm just going to go negative 2, 2. We don't know quite what the period is yet. We haven't sort of calculated that on our own. Let's just take it out to 15 and see what we have. Okay, so I see a little bit of the repetition at least. I might take that a little bit further even in the x direction. Maybe bump it out to 20 just so I can see maybe one more part of a cycle anyways. Okay, so first question, part A. At what time did the first high tide occur today? Well, that is just asking us for a maximum. And we can do that one of two ways. If we could probably do this by hand, because that is asking for a high point, we know when working with cosine, that high point is just at 2 because of the phase displacement. I can also, since I have my calculator, do second calc. Do that again, so second calculate or second trace, and just use option 4 and find a maximum, but I'll just need to scroll over so they know which maximum I'm talking about. Scroll, scroll, scroll. I'm just going to go a little bit to the left of that. It wants a left bound, a little bit to the right of that maximum. I don't have to guess, just go ahead and hit enter. And you can see that should be exactly a 2. We know our calculator does that sometimes. 2 comma 7. So let me write that point down and then let's think about how do we interpret. So we found 2 comma 7. So that would mean 2 hours after midnight. So 2 a.m. The depth is 7 feet. Not that they, oh yeah, they do ask about that, right? How deep is the water at that time? So at 2 a.m., depth is 7 feet. Okay, and that would match up with our upper bound as well, right? That's 7. The period of the function, let's think through that one. So that pi over 5.7 is the reciprocal of the horizontal dilation. So here's our horizontal dilation, 5.7 over pi. Remember, pi is just 3.14, so it's between 1.5 and 2. I'm just sort of estimating. So to find our period, we're going to take the old period times the horizontal dilation to get the new period that we're looking for. Now, because this is in radians, we're going to do 2 pi, I'm going to put it over 1, times our horizontal dilation factor that we found. The pi's cancel out. The period is just 2 times 5.7, or 11.4 hours. So this repeats every 11.4 hours. The tide goes, the high tide, low tide. It's just, we keep seeing it cycle over and over and over again. Okay, now let's use that and what we found in A. It says, when does the second high tide occur? Well, if we know that 1 is at 2 a.m., plus this period of 11.4 hours. Now let's be careful with that 0.4 hours. 0.4 times 60, that's really 11 hours and 24 minutes. That would take us to, from 2 a.m., adding on another 11 hours and 24 minutes, it would take us to 1:24 p.m. And you could do another second calc maximum. You would just have to convert that decimal again that you get into an actual time. Part D, the tide is completely out when the depth calculated for the water is 0 or less. Between what 2 times is the tide first completely out today? So when they say the depth is 0 or less, we need to interpret that as a y equals 0. And we're really trying to work through this solution. If we set that equation equal to 0, what is the x value to go along with that? But our calculator can do that really nicely for us. We're going to put in y2 a straight line at 0, and we can kind of see visually here all of the times that it's 0 or less. So what we're looking for are these two values here. Make those a little bit. Okay, because it says between what two times is the tide first completely out today. So we're going to do 2 quick intersections on the calculator. Okay, so I'm going to do a second trace, option 5. I'm going to intersect, I guess I could find that one since I'm here. Okay, so I've got an intersection at 9, pretty close to 9, right? 9.011. And the other one, let's find that guy. Just move a little bit closer to it. 6.388. So let's record those. Okay, so we've got x values of 6.389 or so and 9.011 converted to times. So remember, that is hours after midnight. So 0.389, that if we multiply by 60 is 23 minutes. So it's between 6:23 a.m. and that 0.011 times 60 again is still pretty close to 9 a.m. It doesn't make a significant difference there.